Hi folks, we're going to take a look at page 12, number 5. So let's start by looking at the question here. So we've got a tropical storm that takes on this circular shape, and as the radius of the storm increases, so is the area going to increase. So not surprisingly, the function we're looking at is a of r equals pi r squared. Okay, and they want us to graph this function on this domain. So we are restricting the domain, and of course this allows us to get used to our new interval notation from 0 to 10, including both of the endpoints. Then they want us to state the domain and range. I guess the domain we already have. They've given it to us in the first part, but we'll have to find the range. And then they want us to describe the similarities and differences between this given function and the general quadratic function y equals x squared. Okay, so let's take a look at this. Alright, so let's start by writing out the function. So we have a of r equals pi r squared. So here, if I just write this function as is, the assumption is that there's no restrictions on the domain. Although one could say that there's a natural restriction that the radius can never be 0. But they've gone a little further than that. They've actually specified that we're only interested in radii between 0 and 10, including both of the endpoints. Okay, so let's start by graphing this function. So you notice I'm not going to go crazy trying to make this a perfect graph. I'm only interested in positive x values, so this is why I set up my axes this way. I'm only interested in positive y values, so there's no point in drawing a bigger graph with the negative portion. Okay, and here I'm going from 0 to 10. Okay, and I'm going to use my knowledge of quadratic functions and realize that this is a quadratic that opens upwards because the leading coefficient of pi is positive. Okay, and because of the form that I've got, I can tell very easily that the minimum is at 0, 0. Okay, so I'm interested in this portion here, minimum at 0, 0, and I know that it's going to be increasing, and then eventually I'm going to stop whenever it reaches 10. Okay. Now one thing that we often do in these graphs is to specify that this endpoint of 0 is included as opposed to being excluded. I use a closed circle. If I wanted to exclude it, I would use an open circle. And same thing here. Once we reach 10, I want to include that y value, that point at the end. So again, I use the closed circle. Okay. So here's our domain. From 0 to 10, so this is already given to us. Okay, now notice here how I don't have to use the curly brackets and say x is an element of r. This assumes that we're talking about the interval from 0 to 10, and it assumes that we're talking about all real numbers. Okay, so to find the range, well, I know that my minimum value here is at 0, and I know that this function is always going to be increasing as x remains positive. So I know nothing funny is going to happen in between, so my largest value is just going to occur at 10. Okay, so to find this largest value in the range, I just have to calculate a at 10, which is pi times 10 squared, okay, which is 100 pi. Now, while this is an application question, and usually I tend to approximate when I'm dealing with an application question, I'll just leave this as 100 pi. So it's about just over 300. Okay, so now we can write out the range. The range again starts off at 0, which is going to be included, and then ends at 100 pi, which is going to be also included. Okay, so there's our domain and range. So now the last thing we want to do, we've answered the first two, is we want to compare this function a with our standard quadratic function x squared. Okay, so let's maybe look at similarities first. Okay, and let's write down a couple of similarities. Well, I suppose they're both quadratic. Okay, or we can even use our new language. They're both second degree polynomials. So both second degree polynomials. Okay, they both have positive leading coefficients, so they both open upwards. So positive. Okay, now you're going to start to see how much shorthand I use here, to try to make things simpler to write but fairly clear. So here, this is my little shorthand for positive. So positive leading coefficient. Okay, meaning that, okay, so this means implies that they both open upward. Okay, probably other similarities we can look for, but let's stick with these and let's look for some differences. Okay, well, one difference for sure is that this function here has no restrictions on the domains, whereas this one here does. So here, domain of y equals x squared, okay, is all real numbers, but domain of a of r is 0 to 10. Okay, so one has a restricted domain, the other one doesn't. What other kinds of things can we come up with? Well, here the leading coefficient is 1. Here the leading coefficient is pi. So again, having studied quadratics, I'm going to be a little more precise here, is that the function a is a vertical. Okay, so it is a stretch. Now because pi is greater than 1, okay, it's an expansion as opposed to a compression. So here I can say a is a vertical expansion of y equals x squared. Okay, and in fact we could have been more specific here, a vertical expansion by a factor of pi. Okay, I think that's enough. I think those are the main differences here. So just to recap, okay, make sure you're comfortable working with function notation. Here, in particular circumstances, we may want to restrict the domain of a function because we're only interested in certain values. Okay, so that gave us the domain, and with our knowledge of quadratics, we were easily able to find the range, and then here we can see the differences and similarities with our most basic of second degree polynomials. Okay, that's it for this one.